tonight we're going to use a model to solve an equation. So far we've done guess and check, which is really systematic trial. It's not random guess and check. It's smart guessing, which I guess you'd say is systematic trial. And now we're going to look at another way to actually model it. Modeling it is using real or manipulative type things to be able to model an equation and then solve it, visualize it. So here I have created a balance. It looks like kind of like the pan balances we've used in science, except that it's a balance on both sides. That the left equals the right if it's horizontal. Okay? So that middle point there, the fulcrum, you can think of it as an equal sign. So we can use this to model solving an equation. You can visually see what it would look like. Take, for example, the equation 2x plus 5. I'll write it up here. 2x plus 5, maybe different color. 2x plus 5 is equal to 7 plus 4. Okay, so if this is my equation, I can model that. This equal sign is going to correspond to the center of the balance. That means what's over here will need to go in this pan. What's over here will need to go in this pan. And if it's a true statement, it will be balanced. This side won't drop down or this side won't drop down. Okay, so how are we going to represent it? We can think back to using it like tiles. Okay, we'll think of this as weight. So here we have 2 of an unknown weight and let's say 5 grams. Okay, so we have 2 of an unknown weight, and I'm going to put that in circle because it's unknown, just so we can. Okay, I've got 2 of these unknown weights, x. We don't know how much it weighs. And I've got 5 grams. That's the left side of the equation. Now on the right side, we don't have any of the unknown weight. We have 7 grams. Imagine these are like little brass weights or something. And we have 4 grams. Okay? So to be able to solve this equation, be able to figure out what 1x is, we have to start doing some manipulation here. And we can, if we keep the balance so that it's not tilting one way or the other, then like if we do the exact same thing to both sides, then we're going to keep the equation a true statement. So for example, if I say, oh, I want to find out what 1x is, so I'm going to throw off 1x. What will happen? This side will pop down. There's no x over here to balance it off by taking it off. So I can't do that. So what do I have on this side that I can remove? So I'm trying to get x by itself that is like something on this side. I have a 5 gram weight, and here I have a 7 gram weight. Couldn't I pull 5 grams out of that 7 grams? Sure. Okay, so I'm going to redraw. Oops. I'm going to redraw here with my green, I think it was. Okay, and I'm going to do a new pan balance. Maybe I should have done a simpler one. And I'm going to make sure that I do the same thing to both sides. So I'm going to draw my 2 x's. That's not changing. Got my x, and another x, unknown weight, and I've got my 5 grams. But over here I'm going to have to put 7 grams into a form where I can take off that weight. So I'm going to turn it into 5 grams and 2 grams and 4 grams. Okay, so now isn't this the same thing? I've kind of regrouped it. 7 grams and 4 grams, it's 11 grams. Now I have 5 grams, 2 grams, and 4 grams. Let me neaten this up a little bit here. It looks ugly. That's my 2 grams. Right? You agree that this would still be balanced. But now I can eliminate this. Take it off. And if I do that to this side, it should still remain balanced. Because I've taken away the same amount of weight from each side. So now I'm left with a much simpler equation. This is not looking like a very good balance. Boy, terrible looking. I've still got my 2 x's, unknown weight, but each one is the same. I've got 2 of them. And on what I'm left with over here now is 2 grams and 4 grams. Okay, so now I think, all right, I've got to figure out what 1x is. I don't want to know what 2x is. So I've got my new balance here. Oh, it gets worse each time. Let me try that again. I've got my balance here. I'm extraordinarily bad at drawing. Okay. I've got 2x, and I've got 2 grams and 4 grams. I can't take off an x here because there's no x here to take off. I don't know what it is, but I can use some logic. If this weighs the same as this, can I make this so that each one of these is the same? So that then I can say, I know what 1x weighs. So let's see what that would look like. What if we redistribute? So we got 2x. Instead of 2 grams and 4 grams, what if I changed it into 3 grams and 3 grams? Okay, if this together weighs the same as this, then that must mean that if I take away one of these and take away one of these, that it will still balance. Therefore, my answer is x is equal to 3. Okay, and we can always go back to our original equation and test that out. If this is 3 grams and 3 grams and 5 grams, that means on the left I have 11 grams. On the right I have 11 grams, so it must be correct. X is equal to 3. Okay, so this is how we can visualize it. Here's a digital one you can find online. I'll put the link to it. And you can use, you can make your own problem, although it's a little bit weird, or you can ask it for a problem. I've created this problem. 3x plus 5 equals 8. So the first thing you want to do is model it. And this is a little bit different in that you only ever have 1 gram blocks. Okay, so the 5 here will have to be represented with 5 of these 1 gram blocks. I can't just have one block called 5 grams. But I think this is maybe even a better way to do it. So first of all, I'm going to model this by dragging over 3x. We don't know what the weight is of x, but we know we have 3 of them. And if you add 5 to that, 1, 2, 3, 4, 5, that's going to be the same weight as 8 grams. 1, 2, 3, 4, 5, 6, 7, 8. And it balances out. So we can see that this is, this is balanced. We have a true statement. 3x plus 5 grams is equal to 8 grams. Okay? We're going to continue on. How can we figure out what 1x is? So I'm going to solve for x using the operations below, keeping the beam balanced. So 3x plus 5 is equal to 8. We're trying to get down to just 1x. This stuff here is in the way. So why don't I take it off? If I did that, this side would tip down. So what am I going to have to take off from both sides? I'm going to have to subtract from both sides 5. Okay, let's see what that looks like. Go. Good. It did not tip. It did not fall over. So that means that I've made a true statement again, that 3 of that weight x is equal to 3 grams. Now it becomes very simple to see, well, what is 1x? If I have 3 of them, and that's equal to 3, 1 of them must equal 1 gram. But really that operation is division. I'm going to divide by 3 to find out what one of these blocks weighs. So if I divide that by 3, and I divide 3 by 3, I'm going to get x equals 1. And that's correct. Okay, here's another example. 2x plus 3 equals 9. My first step is to model the equation. So remember, this equal sign is right here in the middle. The left side of the equal sign should be here, the right side over here. So I'm going to first of all grab 2x. We don't know the value of x. We don't know what it weighs. And then we have plus 3 grams. 1, 2, 3. Now on the right side, to make this balance out, we have to have 9 grams. So I'm dragging over 9 of these. and it should, as soon as it should actually start getting more and more balanced as I go, but this thing isn't that sophisticated. Once I have 9 on here, pop, it'll go horizontal. Okay, so now I have to figure out what 1x is, solve what x is. So I'm going to continue on here, and what is it that I can remove to make it easier to figure out what x is? All right, sorry, I was interrupted. So I have 2x here. I want to get down to 1x, but there's all this stuff in the way, these 3 grams here. So can I remove this and still make this thing balanced? Yeah, if I take away 3 from this side. So I'm going to subtract 3 from both sides. Boom. Now we're down to 2x, and we've got 6 grams. So you can see that if I took away half of this, took away 1 of the x, that would be equal to half of this. So really I'm dividing this by 2 to get 1x. Divide both sides by 2. Put this into 2, and you could see that I would end up with x is equal to 3. Correct. Yay. Okay, so that applet that I was showing you, where you have a little box for each gram, if you're using the balance metaphor, is great, except when you have to do this on paper and you got to write 24. It's a bit nuts. So we can write it this way, as I was showing in the first example on pen and paper. We can write our 2m here. M. Do I write 2m? No, I write m and m. And then we have a weight. 4 grams. Okay, and then on the right I can just draw a little thing that says 24 grams. Okay, so we can visualize this now. It's a little easier than writing out 24 of these little boxes. But what are we going to imagine there's 4 of these? We're going to take away 4 grams from this side and take away 4 grams from this side. And then you can just redraw your balance, showing the next step. Your balance is still balanced. It's still equal in the middle. We got 2m. We got rid of the 4. Take that away. And take away 4 here. And we'd be left with 20 grams. And now we can visualize we don't have 20 blocks, but we can say, all right, if 2 of these is worth 20, 1 of them must be worth 10. Dividing by 2. So we're going to end up with m is equal to, oh, my balance gets worse and worse every single time, equals to 10 grams. Okay, and that's solved. Try the little quiz. It's very easy in Edmodo, and that's it.